very quickly, let me intro myself. My name's Mitchell Hasimoto. This is my Twitter handle and my gravatar that I use everywhere. Maybe you recognize it, maybe you don't. I wrote a piece of software called Vagrant. So if you use that or have used it or have heard of it or haven't used it, then vagrantup.com. But this talk isn't about that. So that's all I'm going to say about that. I work for a company called Keep. We do mobile advertising in San Francisco. I'm an ops engineer, so I actually don't do Ruby all day anymore. I haven't in a couple of years, but I do it. Well, I do it every day on open source, but I haven't done it in the work environment in a couple of years. And I need to thank EngineYard because they sponsor my open source work, so they're the reason that I'm able to come here and talk to you about things like this. That's pretty cool. So very quickly, before I get started, I do want to put up a disclaimer, which is that this talk has opinions in it. It's about things that are not written down in some rule book. It's about things that are community, the community is kind of accepted, but they're not rules, so they are opinions. And some things are more opinionated than others, and I'll warn you. So you're free to disagree, and it's cool if you do disagree, just talk to me about it. But I've been working with Ruby for I think this is year 7, and this is kind of what I've learned over those 7 years. So what's a good Ruby library, and why do you care? So I asked this actually many months ago. I asked people what makes up a good Ruby library, and I fielded a bunch of responses. And in general, the most common response was it has a good API, and I replaced that with intuitive. So they said, I could get to use it, and it works as I expect, and it does things the way I expect. And when I need to do something differently, it follows the same patterns. And that's a pretty good answer. That's definitely an important part of a library. And this was, I wish I had numbers, but this was the vast majority of responses. It was it feels right, or it looks good, or something like that. But there's a ton of other parts involved in a library. And if you're a library maintainer, I'm sure there's a lot of us in here that are library maintainers, or if you've ever planned on writing a library, which if you're a Ruby developer, you probably will at some point, or if you want to contribute to a library, or even if you're just using it, these are parts that you'll run into. And at some point, you'll wonder, how do I do this? How does the Ruby community accept this sort of thing? And these are the parts I'm going to talk about today. So a not exhaustive list of what I'm talking about is configuration. How do Ruby people configure their libraries? Logging, really important, gets really strange. Exceptions, proper exception hierarchies. Do I write custom exceptions? When do I use standard exceptions? Stuff like that. File hierarchies, so where do I put my Ruby files? Where do I put certain tests? What do I name the files? Stuff like that. Tests. We're pretty good about tests, but I'll just talk about it for completeness. And that's just a handful. I'm going to talk probably about double those, but et cetera, et cetera, et cetera. And so if you've ever, even if it's not Ruby, whenever you come to any new language and you plan on writing a library, you always run into these questions where it's I know I need to configure this library, but how does this community do configuration? Do they do any files? Do they do configuration through code? Do they write DSLs? How does it work? And all of them work, but what's the community accepted idiomatic way to do it? So these make up the boring parts, because you never ever go to Hacker News or something and see a post on the top which is here's how I log in my library, and it's 100 upvotes. You never reach that, but you will see 100 upvotes on look at this sexy API. But these parts are equally as important because they make up what is a good Ruby library. If you just have a really good API, it's going to be really fun to start working with it. But then you run into problems, and you start getting weird exceptions, and you want to know what's wrong, so you want logging. And then if you're missing these other parts, you suddenly have a bad library. It seems good, but it's bad. So the whole is greater than the sum of the parts. So I want to talk about all these, so when you work on Ruby libraries, or when you interface with them, you kind of know what's normal and what to expect and what to do. So let's go ahead and jump right in. The first one I'm just going to mention briefly is an intuitive API. It's what I touched upon earlier. And an intuitive API I found generally is just idiomatic Ruby. There's exceptions to this that are popular, but I would say 9 out of 10, more than that, I would say probably like 99 out of 100 libraries just follow normal Ruby. And what I mean by this is like if you were to pick up a Ruby book and try to learn Ruby in a day, which is like basic class structures, basic inheritance, how to instantiate, stuff like that, you'd pretty much know how to use the library. Maybe you wouldn't really understand a symbol or stuff like that, but you know how to use it. And that, in general, makes up a good library. If you're using decent OO principles and it's just plain Ruby, then you're going to get it, and it's going to be good. But that's pretty much all I'm going to say about this because we experience APIs every day. I think, in general, everyone has a good understanding of what is a good and a bad API. So when it comes to Ruby libraries, so I'm just gonna leave it because I trust you guys know it. The next thing is versioning. Versioning is pretty interesting. So every community kind of has their own practice with how to have version numbers, what version numbers mean, when things are safe to upgrade or downgrade. Ruby's pretty much in the past 2 years stabilized on one pattern, and it was published by someone at GitHub. I don't know if it's published by GitHub, but someone at GitHub. And it's pretty much semantic versioning. Everyone that does Ruby is pretty much converging on this, and it's a good thing to follow if you write Ruby libraries. At semver.org, they have like a huge, very exhaustive, detailed list of how versioning should work. I'm just going to go over I'm going to go over the basics here. But I think like Tom Pressenmore has given a whole talk on semantic versioning, which sounds pretty boring, but whatever. So semantic versioning is pretty simple. There's 3 version parts. It's x, y, z. And the 3 version parts are very important. The first one's called the major version, the second one's called the minor version, and the third one's called the patch version. And they all have rules for how you increment them and what they mean. So the major version represents backwards incompatible changes and major new functionality, or major new functionality. So whenever there's backwards incompatible changes, this version must increase. Whenever there's major new functionality, this version must increase. And a special case is the 0 and 1. If x is a 0, it means it's unstable. If x is a 1 or greater, then it means it's reached a stable point. And that's pretty much it for x. Y is a minor release, and it represents backwards compatible changes with functionality additions. So if you add new functionality, you make considerable changes to the internals, but there might not be new functionality. But the required point is it's backwards compatible. You could up Y. And Z is a patch release, and it should be only bug fixes, minor internal changes, the safest thing to change. It should never break pre-existing things. And pretty much everything's fallen into this pattern, I think. There's a lot of ways to do versioning. Like I said at the beginning, disclaiming stuff. There's a lot of ways to do versioning. This is kind of what the Ruby community's fallen onto, and it works really well. It doesn't do odd, even, stable, unstable stuff. Not very many Ruby libraries do that, but you could. It could still be semantic while you do that. So semantic versioning, read that doc. It'll take you like 15 minutes, and you'll just feel a lot better about versioning. Because if someone complains about your versioning, you could be like, yo, it's just this document. You don't complain to him, not to me. But pre-releases. So Ruby Gem supports this thing called pre-releases, which you may or may not know. So on top of the X, Y, Z, there could be a final thing at the end, which could be dev or pre or RCN, or I don't remember. I looked at the Ruby Gems code a long time ago, but I think it could be any alphanumeric thing at the end. And when you do that, when you do gem install pre, it installs that version, but if you don't include the pre, it installs the latest non-pre-release version. And Rails uses this for like betas and RCs and stuff like that. I've used it a couple times. It's kind of cool, but my advice is to just use it sparingly, because unless you have a huge user base where you know like people are going to install pre-releases, or there's a company or something that you know wants to try some pre-release and you're not ready to go, then you could use it. But in general, it just adds more time to your releases, and you should probably have, unless you're like Rails, which is huge, but libraries are usually small, you should have enough faith in your tests and stuff that we'll talk about later to just release and be able to re-release and stuff like that. So pre-releases are cool, but don't go crazy. Like I think, I hope the guy's not here. I think Mongoid, I hate MongoDB, put that on film. It's garbage. I think the Mongoid is not garbage. Mongoid's pretty cool. But I think the Mongoid library went through 18 pre-releases before release, and that was extremely annoying because I just wanted to use it, the features, and it went through a 9-month pre-release cycle. Just freaking release the thing. So yeah, there's that. Are you a Mongoid person? Oh, okay. You're death eyes looking at me. If it's MongoDB, I'm ready. I'm ready to fight. Okay. Okay. Dependencies. So that's versioning. Versioning is really simple and has a really strict set of rules, so it's pretty easy to go. Let's talk about dependencies. Every library, most libraries, have dependencies, which are other gems that you need to run. My first recommendation is always have a gem file in your code. So the gem file isn't used when you release the gem. If you don't know, everyone should know, but Gemfile is a bundler file. Bundler uses it. And what all the Gemfile needs to look like is this. So it just says use Ruby gems and follow the gem spec. And I don't know if you know what gem spec even existed, but that just says read the gem spec and put those gems in this gem file. And the reason why this is cool is because anyone who's used Ruby for any amount of time, for any decent amount of time, is going to expect this sort of workflow with basic libraries. Non-C extensions, pretty simple libraries, which is you could clone it out, you could bundle to get all your dependencies, and then you could rake to run tests. And bundle makes that second step is bundle, but it makes the get dependencies part extremely easy. So, and it's really easy to add it because it's 2 lines. So just include the gem file with it. You can include other groups in there too, like testing groups that maybe you don't want to add to the gem spec as development dependencies or something. You just want to put it in the gem file. You could do that too. The gem spec just says pull those in as well. So that's really important. Whenever I see a gem, it's becoming more and more common now, but 2 years ago, whenever I saw a gem file in a Ruby library, I got all warm and fuzzy inside because I knew how to work with it. More along the line of dependencies is pessimistic constraints. Again, I think this is one of those things that we're getting to, and I'm starting with things that are pretty common nowadays, but the pessimistic constraint is also known as the Spermie operator. This is the Spermie operator. I think you get it. So the Spermie operator is pretty cool. I'm going to say that a lot. Yeah. So the only time I'm going to ask the people here, who doesn't know what the Spermie operator does? Just a handful? Okay. So Spermie 0.8.0, what it does is, well, what happened was, let's go back in time. 6 years ago, Ruby libraries, for some reason, every gem depended on an open-ended, greater than equal some version of a library. And people realized very quickly that's a bad idea because you do greater than equal 0.1, and then 1.0 or 2.0 comes out, and it breaks everything. So people very quickly started saying, OK, I want greater than equal 0.1, but less than 0.2 or less than 1.0 because I know that'll work. And this became so common that the Spermie operator happened. And the Spermie operator means, so Spermie 0.8.0 is greater than equal to 0.80 and less than 0.9.0. So it takes the last version thing and makes that allowed to be anything and strictly less than the next middle thing. So Spermie 0.8.4 is that. And I guess I only did 2 examples. So again, this is, if you follow semantic versioning, then this works really, really well because you could do something like this, and you know this will never, ever break your code, ever. And that just fits into semantic versioning really well. And I think that's part of the reason why we've adopted it so happily. And that's all I have to say about Sperm. So moving on, code style. Code style is something I don't care too much about, but I don't need to say anything because you could just go to this GitHub repository and it's like a 2,000 follower community-driven Ruby style guide where I agree with 99% of what it says, and the 1% doesn't matter anyway. So just do that if you care. When I come to new languages, I happen to care. I'm currently doing a lot of Go stuff, and I happen to care writing Go programs. I hope that this style. Well, Go has a thing that does the style automatically, but layout style, stuff like that. I hope my naming conventions are proper and stuff like that. I happen to care. But honestly, don't sweat it too much because someone's going to call you an idiot, and you'll eventually fix it anyway. So code style doesn't really matter. As long as it works and you have tests and you get all this other stuff right, you're going to be fine. That's all I have to say about code style. It doesn't matter. File hierarchy. So file hierarchy, where do I put, if I have a library named foo, do I put it foo.rb, libfoo.rb, libfoo.rb if you're a Java developer? Like, where do I put this stuff? Gems and libraries actually have a super predictable file layout. That is default. It's all changeable, but the default that people expect are these directories. So there's bin, ext, lib, and test. Test is sometimes called spec. That's fine. But these are the default. And bin contains your executable code. So if your gem ships with like an executable, like Rails ships with the Rails command, then when you call like Rails, it actually calls, I'm assuming system Ruby, like user bin Rails. And that's a stub that looks up your actual gem that calls something bin Rails. And that's how that works. So if you have code that you want to run, you just put that in there. You generate a gem spec with bundler or something, and that's just going to work. Actually, all these things are configurable in the gem spec, so you could change your lib folder, you could change your bin folder, ext, all that stuff. Just don't. Unless you think you have a really good reason, and you probably don't, so just don't. And ext is for C extensions. C extensions are a whole talk by itself, and I'm not that good at them yet, so I'm just not going to talk about it. But that's where they live, and that's where they go. Lib is where the code that your requirable code goes. So when you do a requirable Ruby code, requirable C code goes into ext. So when you do a require foo, it actually goes into your gem and then finds libfoo.rb. That's pretty simple. Test has your tests, and that's sometimes spec. And nowadays, and there's sometimes like, I don't know, whatever Cucumber does, they have some name too. But yeah, so that's fine. But this file layout, it's easy, and you don't ever have to think about it again because you just do this. And people will expect it, contributors will come to your code and be able to contribute much more quickly because they know what's going on, and it'll be normal. It's usually a red flag when you go to a library and it doesn't follow this because you're not sure, the whole entire trust of that person is in question. You don't know. Configuration. So let's step away from the high level, where does my code go, what does it look like thing, and let's go into actual like how you code libraries now. So the first thing is configuration. Ruby's really awesome because it ships with things that are opinionated and work out of the box. But when you want to use it in a real way, you eventually reach a point where you're going to have to turn knobs and configure things. So as a library writer or user, you want to know, how do I configure this thing? The first most important thing about configuration that I just want to like stress on people is make it plain Ruby. So don't make a DSL for your configuration. Don't do like some crazy magic stuff. Make it just like plain Ruby. So objects, attributes, stuff like that. Put it in a central place. So don't make attribute accessors on like 5 classes. So like, yes, I realize the request settings might go on the request class, and the response settings might go in a response class, but just their settings, so put them in one configuration place. Because it makes documentation easier, it makes it look cleaner, and it's easier to find as like as a lost individual. So by central configuration, I mean like something like this. I happen to like this block pattern, but it doesn't matter. As long as you do like, if you have a library named mylib, when I made this talk, I actually was picking on specific libraries, but I decided that wasn't nice. So they're all fake now. So if you do mylib, like you call configure, you know you're configuring that lib. Like it's clear to anyone who sees this. You get a plain old Ruby object in the block. It takes a parameter. A lot of these blocks like magically instance eval the inside, and you get some magic. Like don't do that. You just get a plain old object and you set things on it. Bad would be something like this. So you have a request where you set things and a response where you set things. And yes, this makes kind of sense, I guess, if you could argue it, but it's just harder to figure out where values are coming from, and it's class state, which is kind of a red flag for bad things. Like what if you want 2 requests to go to different hosts? You're screwed. Of course, this is class level configuration. Like you want instance level configuration sometimes. So that should go on initializers with option hashers. That's idiomatic and well understood. So anyone who sees this is going to know exactly what's going on. If you read How to Learn Ruby in 24 Hours, then you'll know exactly how this works. And a quick, on YAML and JSON. So in general, I think that libraries should use Ruby for configuration, and edge-facing, like Rails kind of faces an edge. Things like Vagrant that aren't even used by Ruby people face an edge. Like end-user things could use things other than Ruby, but all the internal glue and stuff should not worry about stuff like this. Just use Ruby. And if the edge-facing things want to use YAML, then they could use YAML and then like pass the Ruby onto the internal libraries, and they're going to deal with it. So don't make some, I don't know, I can't use an example. Don't make some like MongoDB library that reads YAML because the web app could do that for you. So logging. Logging is something I care a lot about because it's something that's been really helpful and hellish for me in Vagrant for the past 2 years. Ruby's standard library logger is actually complete trash. Whoever made the Ruby standard library logger obviously has never logged a real application in their life because it's completely useless. And it's useless for one major reason, is that it doesn't support namespaces. So it's either all on or all off at a level or something. I think they have levels. Yeah, they do. So it's either all on or all off. And when you have an application that has like 50 parts that are all logging, you don't want all on or all off. Because like I know this subsystem's working, I know this one's broken, I only want to see debug level from this. But when you say debug level on and you're getting like megabytes of output, like your program's slowed down because it can't talk to standard out fast enough, it's like, this is garbage. So incoming like super opinion, my opinion, is logging is really boring. So use a library that mimics a community that knows how to log. And people that know how to log include Python and to some extent Java. So like log4r is actually pretty good. It's not the best library. The API is kind of crappy, but it has namespaces and it works. So here's what log4r looks like. From a library writer point of view, you create a logger, mylib connection, and the double colon is a namespace. I don't know why they didn't use dots. Everyone else uses dots. But they use double colons. So, and it's hard-coded. So double colons, and then you just log stuff, and you don't care. And then a user comes along, and they create a logger with the namespace they care about, set outputters and levels. And so this user is saying, I want all mylib namespace things to go to standard error at the info level. So that information string is going to come out. But everything else, every other logging part, is going to be silent. And I mean, I'm a system administrator, so I see like gigabytes of logs every day. And if you're not able to like tune them like this, or you don't have some tool that could tune them like this, then why do you even log? I don't know. But namespaces are super important. So just use something with a namespace, and some basic notes, or don't. So this is interesting. Don't print to standard out or standard error. Anecdotally, I don't know, 99% of Ruby applications cannot handle broken pipes and standard out, standard error. If you take Rails or Bundler and you pipe them to head, they're going to crash. I haven't reported this bug in either because it's so useful for when I give this talk. But sorry, Darren. But you pipe it to head. So for anyone who doesn't know, when you pipe something to head, it like connects the pipes, right? Or it shares a pipe. And when head reads one line by default, it closes the pipe because it doesn't care anymore about output. Then when you want to write to the pipe, it says that pipe's closed and there is an epipe error. And 99% of Ruby programs don't handle it because anytime you write to the I/O, you have to watch for that epipe error. So unless you're wrapping all your I/O, you're screwed. Logger happens to be one of those things. And so if you're logging to standard out, standard error, you pipe it to, I don't know, head or tail or anything that closes the pipe, sed, grep, I don't know, then you're going to crash. Vagrant doesn't crash. Don't rely on a debug config option. So a lot of libraries have like logging, but they don't, it's all on or all off. They don't have namespaces, so they're like, we have a debug option. You either care about our logging or you don't. And that's better than nothing. But in general, like, logging is a layer between something not working and forcing your user to look at your own source code. Logging is that layer where something's not working, you know it's in this area, so you want to enable logging to see what's happening in that area. And if you have this debug option, it outputs way too much because you're outputting stuff from things that people are probably pretty sure at that point work. So you could just skip it. This is also why logging is really important, because it adds that buffer. And don't use something custom, because logging is really boring, and there's things out there that work well enough. Unless you feel like you're going to be the superhero that fixes everything, just don't worry about it. Just use log4r, or there's a couple others that are decent out there, but don't use logger. Don't. I think that's all I have to say about logging. Yeah. Exceptions. Exceptions are fun. Without exceptions, without custom exceptions, you get abstraction leakage. And what do I mean by this? So say you're writing a Twitter library and you tell Twitter to socialize, and then you run it and you get this unknown socket domain socket error thing. That's, like, obviously to us, it has to use a socket under there. But I don't care, honestly. So why do I get the socket error? What does it mean? In this case, DNS is probably down, but I don't know. It's just leaking abstraction out from inside the library out to the user. So libraries should really at least in Vagrant, my stance is if an exception that doesn't inherit from Vagrant error pops out of Vagrant, then it's a bug because I'm leaking some sort of abstraction in there. I take this with most libraries. I don't care that it's a socket error. Just tell me how to fix it. I don't know what this means. So single parent exception class, really useful. If you have a single parent exception class, then you could do things like this. Socialize Twitter, rescue any errors that Twitter knows are possible. DNS not being on is a very possible thing if you're a thing using sockets. And then, yeah, you stop. But if some other exception pops out of there, that it's probably a bug in the Twitter client, or a bug in some code that maybe is calling back into your code, some other thing. Be liberal with subclasses. I think Vagrant has over 150 error subclasses, and they're mostly just like class end. They don't have any bodies. They're subclasses just to be descriptive, because with descriptive subclasses, you get stuff like this, which is you got a Twitter connection error, so it failed to connect to Twitter. You get like a message, and now I know maybe I should try pinging Twitter. Maybe I should try curling it myself. Like it's much more clear than what a socket error could be, which I guess, socket error is not a great example for us. We'll know what it is, but it could get worse than that. SSH libraries get really screwed up. But don't go crazy, so use standard exceptions where they make sense, because they make sense in a lot of places. So if you take an option hash and you require one of those options and it's not given, don't raise like a Twitter missing this option error. Instead, just raise an argument error with a message, because that's what it is. So use it where it makes sense. Obviously, you could claim that a socket error makes sense, but I don't think it does. It's a gray area. But that's that. Testing. So testing. We're all Rubyists, so like high five, we're probably pretty good at testing, which is awesome. When I give this sort of, I haven't, but when I talk to like Python people, it's the opposite. It's high five, you suck at testing. So framework choice doesn't matter. I don't care if you use RSpec, or I don't care if you use test unit, or Minitest, or something else. Riot, I don't know. There's like 80. It doesn't matter, but just make it easy to run, because that's all that matters. So easy to run for most people is Rake. I think since the beginning of time, just running running tests is like the obvious thing. If you're a more complicated project, it might be like Rake test unit, but just Rake. Make it easy to run, and I don't care what it's written in. I just want to make sure, like, if I'm contributing or if I'm using a library, that it works. And that's how it'll work. Acceptance tests. Something I learned really late is you'll want these. I didn't add these in Vagrant until 2 years after I started writing it, and they've been amazing. Acceptance tests, they're sometimes called integrate. I'm like I'm gonna steal Corey Haynes' thing. I don't terminology, I don't care. What I mean by this is they're end-to-end black box tests. I don't know if they're acceptance or integration or what you want to call them, but end-to-end tests. And basically, at least in the context of Vagrant, the way that works is it lives outside, it invokes Vagrant, and then it asserts some world state at the end. And it doesn't care what happens in the middle. These are generally slow. They generally test a lot of things at one time, so you want unit tests for the inside. But they're extremely valuable because they catch the huge like WTF errors. Vagrants end-to-end tests actually take 3 hours to run. So I don't run them almost ever, but I do run them before release. So at least run these slow things before release because they do catch the things like, oh, this entire command, this entire use case is broken in some crazy way, where each unit works properly, but maybe I didn't integrate them properly. And it catches things like that. So acceptance tests are really useful. I didn't know I was on this slide. I don't know. As a bonus, use CI. So CI is really awesome. And CI has gotten so much easier with like Travis CI and others. I happen to like Travis CI, so I won't talk about the others. Travis CI is free for open source, and if you have closed source you want to test, you should just pay them. It lets you just push and they run tests, and it runs within a sandbox, so you could do whatever you can install whatever software you want, you could run any tests you want. It's inside a virtual machine or a container, so you could do whatever you want. So you should use Travis. A README. READMEs are so important that it has its own section. The README obviously is important because things like GitHub and Bitbucket have decided that they're important enough to just show you as the homepage of your repository. And so it should have important information in it. In general, the information I like to keep in it is the name of the library, even though it might be redundant with the repo name. It's good to have it. Description of what it does, like a high-level, like couple sentence description, so I could even know if this is what I'm looking for. Basic feature breakdown, so I could see like if it does say yes, it's an SSH library, but does that mean it also supports SFTP perhaps? Like I don't know. So I like to see features. Examples are good. Then you could quickly sanity check the API to determine if this is something you want to use or not. And contribution info and basic contribution info. You could make a contribution file for detailed stuff, but basic like how do I get it, how do I run tests, and so on. So make a README. I think GitHub makes this like they use check a box now, but get stuff like this in there because people will look for it. Documentation. So high five, you're a Rubyist, you really suck at this, which is the opposite for Python because they're really good at documentation, but they suck at tests. So we have that inverse going on. Documentation, so the company I work for is a Python place. So I've been doing Python for, I don't do Python, I'm an ops guy, I don't care. But I've been looking at Python code for like 2 years, and their documentation is so good. It's so good, it's ridiculous. And Ruby's standard library, like it might as well not even exist because half the time I'm in the Ruby MRI VM trying to figure out how things work. So I wish we could get a lot better at documentation. And I think one of the reasons is we don't write it from the beginning. So like write documentation from the beginning. We write tests from the beginning. And actually the reason why Python sucks at tests is they like don't care enough to write at the beginning, so they try to write it later, and then they think it's the worst thing ever. And that sounds a lot like how I felt about documentation before I started writing it from the beginning. So yeah, if you write it from the beginning, you might be writing documentation for things that you're going to remove, but you usually don't remove things, and at least for a while, and you have it. You just have the documentation done. So you wrote like, you're working on this library and it does 10 things, and you work on one thing at a time, and then by the time you're done, you're like, holy crap, I have documentation for everything. So write it from the beginning. The next thing is super opinionated, but keep the documentation with the code. For APIs, this is a no-brainer. Like, this isn't an opinion at all. It just makes sense to put it on code. But for tools and like stuff like that, it makes sense to just put a docs folder or something, because that way it'll track the commits. So you could like go back to tags and you have the docs at that time. It makes it easier because you could commit it with your commit. It kind of forces you to like commit it. So like Django, you probably know Django. It's like Rails for Python. different mental paradigm, but same idea, web framework. They don't accept any patches unless it has code, tests, and documentation. They won't. Rails, I think, is code and tests, but Django is like definite no unless it has documentation, and that is an awesome like point of view to have. That sort of like dictatorness only works with a giant project, but the same idea should, as a mental discipline, should affect you. You should say, I can't commit this feature unless I know that whatever I just committed is documented somewhere. Opinions coming. API, I like to use Yard. Yard is awesome. It does a lot of cool things for you, like linking between methods. It could read like custom DSLs. You could program it to read custom DSLs to document that. It's cool. I know that there's GitHub people here at the conference. I don't know if there's any in here, but they have like something like TomDoc, and I really hate TomDoc because if their argument is like you'll look at the code, so the documentation is with the code and it's human readable, but my whole thing when I'm using a library is I really, really don't want to look at the code. Like I want the external interface to work, and I don't care how it works on the inside. So for that, I would rather just see API docs on a website that I could click around. Other stuff, if you have like a tool, or if you want a full website and that's not API docs, I recommend just like Markdown and Jekyll, or there's really awesome Jekyll alternatives nowadays, like Middleman and stuff. But I just recommend like some static site generator and keep it with the code, and do that there. So those are my opinions for those things. Last thing, I think this is the last thing, support. So this is a weird thing. People don't usually think about this when they make a library, but if you make a library and you just like put it on, just like pushing your code to GitHub and clicking the open source button is not that useful, because like in my point of view, unsupported code is not really open source. It's just like a reference manual. If I see code that's been pushed and I don't see a way to submit issues, if I don't see a way to talk to the maintainer, like I've never used a library in any production environment for years and not found a bug with it. Like even at the low level, like in the past 3 weeks, I found a bug with libc, I found a kernel bug, and I found an Erlang runtime bug. Like everything has bugs, and if you have no way to report these bugs, then it's not useful at all. Might as well just write it yourself, because then you're going to understand the whole system and you'll know it. But don't write it yourself. So support your code, and that doesn't mean you need to sit online every day and answer every issue yourself or every IRC message yourself. You don't have to do that. Just it doesn't have to equal work. Mostly, you just need some way, some channel that is one channel or a couple to get support. So that means make an IRC channel and tell people about it. Make a mailing list. Maybe you'll never post in it, but at least everyone who uses your library has one central place to talk about it. Just do something like that. So when you have all these things and you finally put them together, you end up with a really great Ruby library. I guess you could probably say great library for any language, but I know Ruby, so you end up with a really great Ruby library. You're kind of like covered across the spectrum on configuration, logging if things go wrong, tests if things go really wrong, and you need to like contribute back to it, support. You're pretty much covered across the board. So these were the boring things, and I hope it didn't bore you too much, but they're questions that would come up anyway. So thank you, and I'll take questions. I have 2 minutes if my 1 minute lateness didn't count. Cool. Any questions? Back there? What? 2 minutes, can't talk about my hate with Mongo, so I'll talk to you after, but I have references to the I have references to the code where like complete idiocy happens, and like memory mapping 100 gigabytes into memory and like being like, oh, the kernel will handle it is like not how databases work. So I'll give you papers from the 60s. It's all wrong. It's never going to work. You're going to have a bad time. Okay. Question. Yeah.
Do you have a particular library that you think hits every point?
Oh, that's such a good question. That's a really good question that I didn't think of. Really good library. Oh, God. No. There's a lot of good libraries out there, but put on the spot, I don't know. I'll think about it, maybe tweet about it or something. Yeah. Any other questions? Yeah.
Are there any examples, say, in Vagrant, where some of these things have come back around to bite you one way or the other?
Like some of the things I said.
Any of these points, are there any examples where you wish you had done this in Vagrant and it's caused you pain and you fix it later?
Yeah, I would say the biggest part is logging. I didn't even have logging until like a year ago, and it's been amazing to have it, but then I did logging too verbosely. I basically had an on-off switch and not namespaces. So when there was a bug, I would be like, oh, attach the log, and then the log would end up being like 30,000 lines. And I couldn't find the spot that was wrong. So I've added log levels, namespacing, and usually a few back and forths with people, telling them where to namespace things. And because a lot of the Vagrant bugs I can't reproduce on my machine, because it's like, oh, this is failing when my host is Fedora and my guest happens to be this specific version of Ubuntu. So I can't reproduce it. So I send them basically code where I'm just like, this enables these namespaces and stuff, send me the output. And a few back and forths, and I could usually track down the bug. Much better than 30,000 lines of output. Yeah. But other than that, I would say I haven't been bitten really hard, but I've definitely been bitten by every one of these at some point or the other. Another question?
I have another question on support. I think some of us don't think about it, but I think some of us are also a little worried. Hey, I'm going to create this open source project. People are going to start using it, and it's going to grow to the point where I can't support it all. I think Wayne ran into this a little bit with RVM.
I mean, if your project gets that big, but if you have like the mailing list, like at this point, I rarely respond. I didn't mention this in the talk, but I rarely respond to the Vagrant mailing list. I actually cheat a little bit. I have my mailing list for Vagrant hooked up to Salesforce, and it only notifies me of emails that don't have a response within 2 weeks. So I actually don't see any mailing list messages unless they're unresponded for 2 weeks. And that's just because it reached the point where I was spending so much time on the mailing list that I wasn't able to work on my project. And at this point, like so many people help on the Vagrant mailing list correctly that I don't care about it. I care about it, but it just handles itself, which is really awesome. So I'd say I would hope that happens. Yeah. Anything else? Good. I'm over time, so I'm done. So thank you.